Well, hello 4C. I've already recorded this video once and there was no sound, so I hope I can get through it this time. Um, Welcome to Solving Linear Equations. Okay, this is nothing new to you. This is actually a review probably going all the way back to grade 9, and you've used it every year since. So we're just going to recap it all again and hopefully you remember. So our goal for today, I can solve linear equations. What's a linear equation? Well, a linear equation is an equation that has a variable in it, and to solve it means to get that variable by itself. So just to read this here, when you solve a linear equation, your ultimate goal is to isolate the variable, usually an x. To do that, you strip away anything that is with it using inverse operations. And of course, when you strip away something on one side, you have to do the same thing to the other, which is the golden rule of algebra. Do unto one side of the equation what thou wouldst do unto the other. So always do the same thing on both sides of the equation. Whatever you do to one side, you do the same thing to the other. The first thing I want to talk about is what an inverse operation is. Hopefully this makes sense to you. An inverse operation just means how do you undo an operation. So to undo addition, if you add something to get back to where you started from, you would have to subtract. If you multiply something to get back to where you started from, you would have to divide. And this one here is the square root. If you take the square root of something to get back to where you started from, you would square it. So we're going to square that something. And of course, the other direction is true as well. These work both ways. The inverse of subtraction is addition, the inverse of division is multiplication, and the inverse of squaring something is square rooting something. So we're going to start off by doing a couple of examples here. And we'll start off with a really simple example that just has one variable on one side of the equation. Now remember, our ultimate goal is to get this x completely by itself. So to start with, we're going to get the term that has x in it completely by itself. And so what we say to ourselves is, what is stopping this term from being by itself on this side of the equation already? Well, the only other thing on this side of the equation is this minus 2. So that is stopping 3x from being by itself. To get rid of a minus 2, we have to add 2. And don't forget that golden rule of algebra. Whatever you do to one side, you have to do exactly the same thing to the other. So I'm going to have to add 2 on this side as well. Now, if I add 2 to both sides, this is going to go away, and the only thing I have left on that side is the 3x. And on this side, I have a negative 11 that I'm adding 2 to. Don't forget your integer operations. These two positives are going to cancel out 2 of those negatives, and I'm left with 9 negatives. So now my goal of getting the term with x in it all by itself has been completed. And now I just need to get this x by itself. So what is stopping this x from being by itself? Well, the answer to that is this 3 on the outside. This 3 is multiplying the x. That's what it means when there's nothing in between them. And so the inverse operation of multiplying is dividing. We don't usually use this symbol. We usually put it over. So it's like a fraction. And then those will go away, but the golden rule of algebra says whatever I do to one side, I have to do the same thing to the other. So I have to divide both sides by 3. Now on this side, I'm left with just an x. On the other side, I'm left with a negative 3. And that's my answer. X is negative 3. Now what that means is if I put this negative 3 up where this x is, 3 times negative 3 gives me negative 9. Subtract 2, negative 9 subtract 2 is negative 11. And so I get what's on the other side of the equation. So this value made this equation true. And that's what it means to solve the equation. We want to find the number that I can put in place of that x that will make the equation true. So moving on to the next question. When you have variables on both sides, get them to one side and the numbers on the other. So we want to pick a variable side and a number side, and it doesn't actually matter which one's which. Usually people like the variables on this side and the constant term or the number term on this side. So that's what we're going to do here. So if I want the variable on this side, I have to get rid of anything on this side that is not a variable. So when I say not a variable, this -5 is part of the variable term. Remember, we have to keep the terms together to start with. So this is okay on this side. I want variable terms on this side, but that means I have to get rid of the +3. So I'm going to subtract 3, and whatever you do to one side, you got to do the same thing to the other. So I'm going to subtract 3 on that side as well. So those are gone, and I'm left with just -5x on this side. And on the other side, I have that 7x still. Nothing happened to that 7x. And when I put in these -3's, we'll cancel out 3 of those positives, and so I'm left with +12. Now that I have only variable terms on this side, I'm going to turn my attention to the other side, which says I can only have constant terms on this side. So this is what I want to keep on this side of the equation. That's a constant term. It needs to stay there. So I have to get rid of the other one. This 7x, the opposite of a positive 7x, is a negative 7x. And I'm going to put negative 7x on this side because whatever you do to one side, you have to do the same thing to the other side. And notice I'm using the terms negative and subtraction or minus kind of interchangeably. In algebra, they basically are interchangeable. Subtracting and putting on a minus something or a negative something is very much the same thing. So over here, this +7 and -7 cancel each other out. So all I have left with on this side is 12. And then a -5 and a -7. Remember your integer rules. If I have 5 negatives and somebody gives me 7 more negatives, I now have 12 negative x's. Now we have to get the x completely by itself, so I have to get rid of what's stopping the x from being by itself, which is this -12, and it is multiplying the x. So I have to divide by -12 on both sides in order to get rid of that. So these go away, and all I'm left with is an x on this side, and 12 divided by -12 is -1. And there's my answer. The value of x that will make this equation true is -1. Okay, moving along to the next page. We got 2 more examples to go through. This first one, we have to do the example and then we have to check it. And this is called a left side, right side check, and we'll talk about it in a minute, but I'm also going to shorten what I'm doing here. So here's what we're going to do. This side is the variable side. So that means that I want to keep the variable here, but I want to get rid of the constant. So I'm going to get rid of that -2 by adding 2 on both sides. And I'm going to make sure that I always put that +2 with the constant because it is a constant. So even when I put it on this side, I want it to line up with the constant. So I put the like terms together. So that's my variable side. Now I'm going to go over here. This is my constant side. That means I want constants over here. I don't want variables. So I need to get rid of this variable. A positive 7x we can get rid of by putting -7x with it because positives and negatives cancel each other out. So this is going to be gone and this is going to be gone. And remember, if I subtracted 7x over here, I have to subtract 7x over here as well. So now I just have to simplify these two things that are left over. And I did this all in one step. Instead of going through the multiple steps that were over here, down here, instead of going through these multiple steps, I did it all in one step here. So +8 and -7 gives me just positive x. And on the other side, I have -9 and +2. These two positives are going to cancel out 2 of those negatives, and I'm left with -7. So x equals -7. So that was a whole lot quicker if I do that all in one step and just get rid of the stuff that I don't want on each side of the equation. And now this tells me that the value of x that's going to make this equation true is -7, and we're going to check to make sure that that's the case. So when I do a left side, right side check, I keep the two sides. Remember, it's the equal sign that's in the middle. I keep the two sides separate. So I'm going to work through this side and see what number I get here. And then I'm going to work through this side and hope I get the same number, because if I get the same number, that means that the number I found over here did in fact make this equation true. So let's see, how does this go? So I'm going to take 8, and instead of x, this means 8 times x. So I'm going to times it by -7. So I get 8 times -7 and subtract 2. 8 times -7 is -56. And when I subtract 2 from -56, I get -58. So this side of the equation gave me -58. Now I'm going to plug -7 into the other side of the equation, and I'm going to hope that I still get -58. Because if I get -58, that means left side equals right side, and I found the value of x that makes this equation true. So this is -9 plus 7 times, and instead of the x, I'm going to write -7. And now I'm just going to do the math. Remember your order of operations. I have to do the multiplication before I do the addition, and +7 times -7 is -49. -9 times -49 is -58. And yippee! It looks like left side does equal right side, so I got the right answer. Give myself a big check mark. Okay. Now those were two fairly simple examples. This next one is a little bit more difficult because there's a lot of stuff going on one side of the equation, and we're going to have to simplify this side of the equation before I can actually solve this equation. Before I can start moving things and doing the same thing on both sides, I have to make sure that both sides are as simple as I can make it, and that's just not the case here. So the first thing I want to do is get rid of these brackets, and hopefully you remember the distributive property from years gone by. If there's a number in front of brackets, what that means is I have to multiply everything in the brackets by that outside number. So that's going to give me -5 times 1, which is just -5. And then -5 times -5x, two negatives make a positive. 5 times 5 is 25, and there's still that x there. Now let's multiply the 5 through. 5 times -8x and 5 times -2. So 5 times -8 is -40x, and 5 times -2 is -10. Now, the other side of the equation, there's nothing to multiply through, but these are like terms. I have a -4x and a -8x, so I can put those together. -4x and -8x is -12x. Now, you might want to pause me here and see if you can finish this question by yourself. So I'll give you just 1 second to pause, and now I'm going to carry on. I want to put together anything that's like on this side. There's still a lot of terms over here, and so notice that I have this -5 and this -10 that are like terms, and I have a +25x and a -40x that are like terms. So I'm going to put those things together. A -5 and a -10, they go together and they become -15. And the 25 and the -40, these are opposite signs. So remember, when the signs are opposite, there's some canceling goes on. So these 25 positives are going to cancel out 25 of those negatives, and I'm going to be left with 15 negatives. So I've got -15x. Now on the other side, I still have just the -12x. There's nothing I can do at this time because all I'm doing in this step is simplifying on this side. I want you to also notice that I'm keeping the equal signs kind of lined up here so that they're all on that. I still have one side of the equation and the other side of the equation, and they're all kind of centered around the equal sign. So I'm actually going to put the equal sign down on the next line, just so I can keep it all centered around the equal sign. That's good communication, good form. Now I want to decide which side is my variable side and which side is my constant side. Now this is one time where it actually makes sense to make this side my variable side because that's what's there. There's no constants over on this side, so I might as well make it my variable side. So if this is my variable side and that's what's there, there's nothing to do over there. Over here, this is going to be my constant side, and on my constant side I need to get rid of variables. So the negative 15x is my variable term, so I'm going to add 15x on this side. But whatever you do to one side, you have to do the same thing to the other, so I have to add 15x on this side as well. So what that means is that this is gone, and I have just negative 15 on this side. And over here, these 12 negatives are going to cancel out 12 of those positives, leaving me with only 3 positive x's. Now, just because my variable's on this side, that shouldn't bother me. I still have to get x completely by itself. And what's stopping x from being completely by itself over here is the 3. 3 is multiplying x, so I need to divide. And whatever you do to one side, you have to do the same thing to the other, so I'm going to divide by 3 on this side as well. That's going to go away, and we have x completely by itself on this side of the equal sign, and negative 15 divided by 3 is going to give me negative 5. And there is my final answer, x equals negative 5. And that's it for our examples. We have a couple pages of homework for you to do here. There's a couple that have some expanding and simplifying to do. If you look down, there's 2 tables here that say left side, right side for 6 and 7. Those are the only 2 that I want you to do a formal left side, right side check, but you can do a left side, right side check for any of the questions. That's one of the few times on a test where you can actually see if you got the right answer or not. And then there's a few that are a little bit more complicated on the back side here. And don't forget that you have answers to check. So make sure you're checking as you go along. And if you're having any problems, get that straightened out before you carry on. Okay, good luck.